Assalamualaikum. My name is Aisha Akhtar. Now I am going to present a paper presentation whose name is A Survey on Platoon-Based Vehicular Cyber Physical Systems. Abstract. A Platoon-based driving pattern can boost road capacity and energy economy dramatically. In this paper, they represent the comprehensive survey on a Platoon-based BCPS. First, review the related work of a Platoon-based BCPS. Then introduce two elementary techniques involved in a Platoon-based BCPS, like the vehicular networking architecture and standard, and the traffic dynamics respectively. Then the first section is introduction. The Platoon-based driving pattern is a cooperative driving pattern for a group of vehicles with common interest, in which a vehicle follows another one and maintains a small and nearly constant distance to the preceding vehicles, forming platoon as shown in figure 1. The topics to be discussed are listed. Explain the basic of Platoon-based BCPS, summarize related surveys in the literature and the distinguished survey with existing ones, vehiculars, networking architecture and standard, and an overview on the basic knowledge of traffic dynamics, platoons or cluster management, cooperative platoon-based driving, Platoon-based vehicular communications, simulations tools for BCPS verifications. Section 2. Platoon-based BCPS. There have three subparts. Number A. Conception. A Platoon-based BCPS can be characterized by the tight coupling between vehicles' physical dynamics and the behaviors of vehicles networks. As illustrated in figure 2, a Platoon-based BCF consists of two planes, a physical plane and a cyber plane. In this paper, they mainly address the inter-vehicles CPS, where the vehicles are considered as the mobile nodes running on roads. Number B, applications. So what kinds of applications that have traffic flow optimization, traffic green and economics, and the infotainment service. Number C, methodology. Clearly, common knowledge reading BCPS is the cornerstone to support Platoon-based BCPS, which mainly involves two general aspects in the term of taxonomy, as shown in figure 2.1. Networking related issues that mainly included vehicular networking standard and the architecture to support V2V and V2I communication. And number 2, dynamic traffic dynamic, that includes traffic flow distribution and the vehicles mobility models. To meet the requirements of Platoon based BCPS implementation, there are several specific issues. On the one hand, in a Platoon-based BCPS, vehicles are supposed to guarantee the Platoon-based driving patterns. To achieve this goal, some fundamental issues such as Platoon management to regulated the actions of platoon formation, maintenance and splitting, platoon attributes, which is stability, analysis and cooperative platoon driving need to be addressed. Section 3. Related service. In these sections, they first briefly summarize the service regarding vehicular networking, traffic optimization, etc. in the literature, then highlight their work in this paper. So in the past few years, several comprehensive surveys have been conducted on vehicles networking, covering various issues including applications, architecture, protocols, and security, most of which are reviewed from the communication perspective. Some other surveys, on the other hand, focus on the traffic flow optimization from the control perspective. Many techniques issues regarding vehicles platooning were discussed, such as obstacle detection and collision avoidance techniques, literal and the longitude control strategies, trajectory planning method, etc. Section 4. So in this section 4, they review the basic knowledge of Platoon-based BCPS from two aspects. Number 1, vehicular networking standard as well as the architecture and the traffic dynamic description. There have some few parts. Number A, Vehicular networking is standard and architecture. Typically, information can be classified into four types: state monitoring, information control, packaging, information data, and warning message. There have also some parts, the VANET protocols. Was that to enable VANET, many organizations and institutions have been devoting to the standardization of vehicular communications in recent years, such as CEN, TC278, ISO TC204, ETSI, TC, ITS, IEEE 1609, and the IETF. Number two, vehicular networking architecture. Due to vehicular mobilities and the limit transmission range of IEEE 802 dot 11p, the VNet connectivity may be intermittent and it may be difficult to achieve the sufficient small handoff latency. To solve this issue problem, one effective solution is to build a hybrid vehicular network architecture, integrate VNet with the cellular network. Number B, modeling traffic dynamics. Traffic dynamics describe the spatiotemporal behavior of the collective vehicles on road, which normal can be characterized in two ways: traffic flow distribution, traffic mobility models. Number one, traffic flow distribution. From the statistic perspective, traffic dynamics can be characterized by certain traffic flow distribution with the several parameters. Among these parameters, statistics time headway is regarded as the most fundamental one, that is defined as the time between two consecutive vehicles passing the same point and traveling on the same directions. Number two, traffic mobility models. So figure 5, so we can see easily the fluid dynamic perspective traffic mobility can typically classify into the macroscopic and the microscopic models. Now section 5, fundamental issues in Platoon-based VCPS. In this section, they first discussed the architecture of Platoon-based VCPS, then reviewed some fundamental issues of Platoon-based VCPS from the perspective of both traffic optimization and vehicular network optimization, respectively. There have few part that consisting of these sections in figure 6 that we have including the modeling Platoon based VCPS. That means explanation is Platoon based VCPS is considered as a complex network control system, and one primary issue is to comprehensively understand the coupled relationship between vehicular networking and traffic dynamics. Number B, in figure 7, Platoon or cluster management. Platoon management is a fundamental functions for Platoon-based BCPS, which involves Platoon formation, merging and splitting, etc. Based on the existing effort, they illustrated the Platoon management system in figure 7. Number C, Platoon stability analysis. Platoon stability analysis exhibits the essential features of intra-Platoon dynamics from the control theory's perspective. Number D, cooperative Platoon driving. Platoon control with the help of vehicular communication significantly improves traffic safety and efficiency. Number E, Platoon-based V2V communications in figure 8 that have explanation to facilitate various Platoon-based applications such as vehicles platooning and infotainment service. As effective design for vehicular communication is a must in Platoon-based VCPS. For a typical Platoon-based traffic scenario, some basic issues regarding vehicular communications are intra-Platoon Platoon communication and inter-Platoon communication. Number F, Platoon-based V2I communication. V2I communication, also called drive to internet access. It is a primary application for Platoon-based VCPS, where all vehicles have opportunities to access internet service from a RSU when they enter into the transmission coverage of the RSU. Now the important section 6, system verification and validation. So in these sections, they first briefly review traffic mobility simulators and network simulators respectively. Then they indicate the requirement for the coupling of two types of simulators to evaluate the system performance. In particularly, they take Venice as a case study to illustrate how the coupled simulator works interactively. Number A, traffic mobility simulators and network simulators. The major function of a traffic mobility simulators is to provide an accurate mobility model of each vehicle as well as the interactions between them in virtual traffic environment, so that relatively realistic traffic information can be obtained from the simulators. This process may be essential regarded as the descriptions of the physical process of the VCPS. There have some few things: traffic mobility simulators, network simulators, etc. Number B, integrated simulators and vanish, which is explanation have figure 9 and 10. To precisely simulated such as a Platoon-based BCPS, a federated simulations architecture is required, which combines the well-developed traffic simulator and the network simulator through general traffic control interface as listed in figure 9. And the number 7, challenges and open issues. So in these sections, based on the existing studies on the fundamental issues in Platoon-based VCPS, they discuss some open issues for future research. Number A, deployment of Platoon-based driving pattern. Number B, communication for vehicles platooning. And the last part is conclusion. Vehicle platooning is a potential driving pattern that has emerged as the current transportation system feature trend. First, demonstrate two basic aspects of Platoon-based VCPS. Number one, the vehicle's networks architecture and the standard. And the number two, the Platoon dynamics, which involve mobility models and control strategy for the Platoon. Then comprehensively elaborate some fundamental issues in Platoon-based BCPSs, including Platoon or cluster management, cooperative Platoon driving, Platoon-based vehicular communication, etc. Thank you so much.